Unfortunately, earlier today the battery went out on the camera, so we're going to have to try to pick up where I left off. I actually don't think it's going to be that hard. I kind of have a sense of it. So we were talking about free fall, and we were kind of relating it to our constant acceleration situation. In our constant acceleration situation, here's the deal. So let's say we have a ball on a ramp, and we release the ball from up here, and the ball's rolling down to here. And in a general sense, we know because it's a ramp, the acceleration is constant. So if the acceleration is constant, we can get a good idea of what's going on in terms of the 5 variables that we're interested in. That's the displacement, that's the change in position, initial velocity, final velocity, acceleration, and time. These are our 5 variables that we use, and we can solve problems like this, given these, and here are our kinematic equations that we use. The change in position, this relates to change in position to the acceleration, time, and initial velocity. Final velocity, acceleration, time, initial velocity. And final initial velocity, acceleration, and the change in the position. What I think is very interesting about these is you have 5 variables, but in each of these 3 equations, you only have 4 out of the 5 of them. And that's what really informs your decision making in terms of which equation you're going to choose to use on whatever problem you're using. Because for this one, for example, you have displacement, acceleration, time, and initial velocity. Nowhere in here do you see the final velocity. Just like this one, velocity, final, acceleration, time, and initial velocity, we're missing the displacement. And this one down here, you have initial and final velocities, acceleration, and displacement, and you're missing the time. So as we go through and we solve these problems, you're always looking for what you have, what you don't have, and that's how you choose. Now, how does this relate to our free fall situation? What I like about the free fall situation is I have the same things. And so, for example, our intrepid physics student drops a ball. We know it's accelerating downward with the acceleration due to gravity or with the free fall acceleration. And so we have our same variables, but here's the difference. When we were over here talking about one-dimensional motion, we always say that this is the x direction, regardless of whether it's slanted or it's really horizontal. But when we're talking about free fall, this is definitely the vertical direction. And so we're going to change our variables to account for the vertical direction. So I'm going to rewrite these. In terms of what we do for free fall. So now our displacement, instead of the delta x, it's the delta y because it's falling in the vertical direction. We call it the v0y because it's the initial velocity in the up and down direction. The final velocity in the y direction. We know baby g is the acceleration, and of course time is still time. Negative 10 meters per second is our free fall acceleration. The 10 is the value. The negative means it's always in the down direction. For that, to consider that for a moment, if I take this marker and I throw this marker upward and it comes back down, we know the acceleration is always down, right? Use our fingers. If this is the acceleration arrow and this is the velocity arrow, when the ball is on its way upward, the velocity and the acceleration are in opposite directions, so our ball is slowing down. It stops at the top, the acceleration is still down, then the velocity switches over, and now it's speeding up on the way down. So the acceleration is always down. That's why it's negative, regardless of the velocity direction. So what does this do now that we have new variable names for our conceptual variables over here? How do our kinematic equations relate over here? Well, they have the same structure, but we're going to replace some variables. So, instead of delta x, it's delta y. Instead of a, it's g. And instead of v0, it's v0 in the y direction. But it's very important to have a framework for what all of this is so that we don't get confused by the extra letters. And then last one. And this is how our kinematic equations manifest in free fall.